These are your notes for Unit 10, Day 3 of Algebra 1. If you would like to see the warm-up review question or any homework questions we covered in class today, just look at the finished notes. So today we're going to learn another method for solving quadratic equations, so equations with a degree of 2. We've learned how to solve by taking square roots, and we've learned how to solve by completing the square. Today we're going to use the process of solving using the quadratic equation by using the formula, the quadratic formula. So we're going to learn what the quadratic formula is, where it comes from, and how to solve quadratic equations using the quadratic formula. So first, let's talk about the standard form of a quadratic equation. So again, a quadratic equation is any equation that has a degree of 2. So standard form looks like ax squared plus bx plus c equals 0. So it's in descending order, and it's equal to 0. That's what standard form looks like. So we're going to put the following two equations in standard form, and then we're going to say what the a, b, and c is. So notice a is the coefficient in front of x squared, b is the coefficient in front of x, and c is the constant, or the number without the variable. If the equation doesn't have an a, b, or c, then the a, b, or c would be equal to 0 if it's missing. So on the first one, we have x squared, 5x squared minus 3x plus 8 equals 2x minus 10. Well, to put it in standard form, I need it to equal 0, so I'm going to subtract the 2x from both sides, and I'm going to add the 10 to both sides so that the right side will be equal to 0. So now combining like terms, I have 5x squared, negative 3x minus 2x is negative 5x, and 8 plus 10 is 18. So I have 5x squared minus 5x plus 18 is equal to 0. So now that quadratic equation is in standard form. A is equal to 5, because that's the coefficient in front of x squared. B is equal to negative 5, because that's the coefficient in front of x. And C is 18, because that's the number or the constant without the variable. All right, let's look at number 2. Negative 7x squared plus 5x minus 1 is equal to 2x squared minus 2x minus 1. Again, let's put this in standard form. So I'm going to get one side to equal 0. So I'm going to subtract the 2x squared from both sides. I'm going to add the 2x to both sides. And I'm going to add the 1 to both sides. So now notice I get negative 9x squared plus 7x plus 0 is equal to 0. So I really don't need that 0, but I'm going to leave it there. So now it's in standard form. One side is equal to 0. So now my a is going to be negative 9, because that's the coefficient in front of x squared. My b is going to be 7, because that's the coefficient in front of x. And c is going to be 0, because there is no constant. So if I rewrote this, I would have negative 9x squared plus 7x equals 0. C would be 0 because there is no constant. All right, so that's standard form. So in order to solve using the process we're going to do today, using the quadratic formula, the first step is we need to make sure that our equation is in standard form. So what is the quadratic formula? We are going to listen to a song several times in class today to help you memorize this from YouTube. But the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So again, our quadratic formula is right here. It's x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So notice when you have your quadratic equation in standard form, you have ax squared plus bx plus c. So that a in front of x squared in the formula goes right there, and it goes right there. So it's part of the 4ac underneath the square root, and it's part of the denominator 2a. And then the b in the quadratic formula comes from the b from ax squared plus bx plus c. So that b, the opposite of b goes in front, and then b squared goes underneath the square root. And then lastly, that constant c from your equation goes underneath the formula in the 4ac. So you're going to plug in those values, and doing so will solve a quadratic equation. The proof. So this, you won't need to memorize this proof, but I'm going to show you where the quadratic equation comes from. If you would like to just continue on with notes, you can fast forward through this explanation. But to do this, we are going to solve by completing the square. So remember, to solve by completing the square, my first step is I'm going to move that c over. So I'm going to subtract c from both sides. And then I get ax squared plus bx equals negative c. To solve by completing the square, well, I need to factor out that a. If I factor out the a, the first part's easy. We take a, and then we have x squared. To factor it out from bx, we divide by a. So if I took bx and divided by a, I would have b over ax, and then that's going to equal negative c. Notice it worked because if I redistribute it, I would get ax squared, and then if I distributed there, a times b over a is just going to be b. So it works. And now we're going to complete the square. Well, remember, to complete the square, you take the b term, which is b over a. So we're going to take b over a, divide by 2, and then square that result. Well, b over a divided by 2 is the same as b over a times 1/2. So that would be b over 2a. And then we're going to square that result. Well, b squared, 2a times 2a is 4a squared. So we're going to add b squared over 4a squared to complete the square. Well, remember, whatever you do to one side, you have to do to the other. But what I'm really doing is taking a times b squared over 4a squared. And if I took a times b squared over 4a squared, I would get just b squared over 4a, because that a in the numerator and the 4a squared in the denominator would reduce. So I'm going to add b squared over 4a to both sides. And then, remember, when you're solving by completing the square, the next step would be to factor both sides. So I get x, and then it's going to be ugly. So what was actually inside the parentheses was going to be b over 2a squared. So that's what I'm going to add to both sides. So that's going to go right here. So plus b over 2a squared equals negative c plus b squared over 4a. Okay. Now I'm going to get a common denominator over here to make my life a little bit easier. So I'm going to times by 4a times by 4a. And so I get a, and then x plus b over 2a squared equals negative c over 4a plus b squared over 4a. And then I'm going to divide both sides by a. And then I get x plus b over 2a squared equals, when I divide by a, I'm multiplying by 1 over a. So this is going to be negative c over 4a squared plus b squared over 4a squared. Notice they have a common denominator, so I'm going to write them as one fraction. And I'm going to write this as b squared minus c over 4a squared. Okay, now I'm going to take square roots on both sides, and then plus or minus. So now I have x plus b over 2a equals this plus or minus the square root of b squared minus c over 4a squared. Well, I can't take the square root of the numerator, but the square root of 4a squared is going to be 2a. So I have x plus b over 2a equals plus or minus the square root of b squared minus c over 2a. And then what did I do? Oops. I didn't rewrite this. This should have been 4ac. Sorry, gentlemen. So minus 4ac, minus 4ac, minus 4ac, minus 4ac, minus 4ac. So when I got my common denominator all the way up here, I forgot to actually write it as minus 4ac in all of those places. And now I'm going to keep solving. So I'm going to subtract the b over 2a from both sides. And then I get x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Notice they have a common denominator, so I can combine them. So negative b plus or minus the square root of b squared minus 4ac all over 2a, which is the quadratic formula. So again, you don't need to know how to prove it, but that is the proof of the quadratic formula. You take your standard form and you solve by completing the square. All right. So now let's actually solve using the quadratic formula. So remember, your steps are, first step, you need to put it in standard form. So you need to make sure your equation is in standard form before you get started. So ax squared plus bx plus c is equal to 0. Then step 2, you're going to plug the a, b, and c into the quadratic formula, which is up above. So plug the a, b, and c into the quadratic formula, and then you are going to simplify under the square root, and that's going to be your answer, unless you can simplify further. So 5x squared plus 1x minus 2 is equal to 0. So it's in standard form, we're good. So now we're going to take the a, b, and c and plug it into the quadratic formula. Well, a is 5, b is going to equal 1, and c is going to equal negative 2. So the quadratic formula is x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So let's plug in to that formula. So x is going to equal the opposite of b. Well, b is positive 1. So the opposite of b is going to be negative 1. So negative 1 plus or minus the square root b squared. Well, 1 squared is 1. Then minus 4. And then a times c. Well, a is 5 and b is negative 2. So a times c is going to be negative 10. So I'm going to plug in negative 10 for a times c. Then the whole thing is all over 2 times a. Well, 2 times a would be 2 times 5, so that'll be 10. And then we simplify under the square root. So x is going to equal negative 1 plus or minus the square root. That's going to be 1, and then negative 4 times negative 10 is positive 40. And 1 plus 40 is going to be 41. So I get negative 1 plus or minus the square root of 41 all over 10. And that is going to be my solution to that quadratic equation. You can write it as two separate solutions, negative 1 minus the square root of 41 over 10, and negative 1 plus the square root of 41 over 10. Or you can leave it as the combined solution with the plus or the minus. All right, let's look at number 2. 3x squared plus 2x equals 8. Well, we need to put it in standard form first, so I need one side to equal 0, so I'm going to subtract the 8 from both sides. And I get 3x squared plus 2x minus 8 is equal to 0. Now I'm going to plug into the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Well, in my equation, a is equal to 3, b is equal to 2, and c was equal to negative 8. So when I plug in, x equals the opposite of b. The opposite of b is negative 2. Then plus or minus the square root of b squared. B squared would be 2 times 2, which is 4. And then minus 4. A times c would be 3 times negative 8. 3 times negative 8 is negative 24. And then all over 2 times a. Well, 2 times a would be 6. Simplify under the square root. So x is going to equal negative 2 plus or minus the square root of 4. And then negative 4 times negative 24 would be 96. So that'll be 4 plus 96. So that'll be 100 over 6. Well, notice this time we can take the square root of 100. The square root of 100 is 10. So it'll be negative 2 plus or minus 10 over 6. So if I separated this out, I would get x equals negative 2 minus 10 over 6, and x equals negative 2 plus 10 over 6. And if I simplified that, I would get negative 2 and 8/6, which is 4/3. So my two solutions are 4/3 and negative 2. So x equals 4/3 and x equals negative 2. All right, let's try one more together. 5x squared plus 1x minus 2 equals 2x minus 1. So if we're going to solve using the quadratic formula, we need one side to equal 0. So put it in standard form. So minus the 2x, add the 1, and we would get 5x squared minus 1x minus 1 equals 0. So plug into the quadratic formula. X equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. A is equal to 5, b is equal to negative 1, and c is equal to negative 1. So plug those in. X equals the opposite of b. The opposite of b would be positive 1. Then plus or minus the square root, b squared. Negative 1 times negative 1 is positive 1. Then minus 4. A times c would be negative 5. then all over 2 times a would be 10. And then simplify under the square root. 1, negative 4 times negative 5 is 20, so that becomes 1 plus 20 under the square root. So we would get x equals 1 plus or minus, the square root of 21, plus or minus the square root of 21 over 10. And those would be my solutions. All right, why don't you pause the video and try number 2. So solve number 2 using the quadratic formula. All right, first step, put it in standard form. So I'm going to subtract the 8 from both sides, and I get 3x squared plus 12x minus 2 equals 0. So quadratic formula, x equals the opposite of b plus or minus the square root, b squared minus 4ac all over 2a. And a is equal to 3, b is equal to 12, and c is equal to negative 2. So x is going to equal the opposite of b is negative 12, then plus or minus the square root. B squared, 12 times 12 is 144. Then minus 4 times a times c. A times c would be negative 6. Then all over 2 times a would be 6. So now I have x equals negative 12 plus or minus the square root. Negative 4 times negative 6 is 24. So I have 144 plus 24. And I get 168. So I get negative 12 plus or minus the square root of 168 over 6. The square root of 168, I'm wondering if there's a perfect square that fits in that. 4 definitely does. So 168 divided by 4, I get 42. And so I can rewrite this as negative 12 plus or minus 168 is 4 times 42. So it'll be plus or minus 2 square root 42 over 6. And then notice I have a binomial on top, but I can factor out a 2 from that binomial. So it would be 2 and then negative 6 plus or minus 1 square root 42 over 6. And then you can reduce the 2 over 6 to 1/3. So it'll be negative 6 plus or minus the square root of 42 over 3. Or notice on this step, all of these terms, negative 12, 2, and 6, are all divisible by 2. So you could divide them all by 2 to simplify your answer. All right. What if there is a term missing, like in number 1? So we have 5x squared equals 3. Now, we can solve this using the quadratic formula, and that's what we're going to do for notes. But notice, if we just solved by taking square roots, like we did in our previous lesson, we would divide both sides by 5, and I would get x squared equals 3/5. And then to solve by taking square roots, you would take the square root of both sides, and you would get x equals plus or minus the square root of 3/5. Would be plus or minus square root 3 over square root 5. And so when you rationalize this, you would get plus or minus the square root of 15 over 5. We can solve this using the quadratic formula as well. So put it in standard form. So subtract the 3, subtract the 3. We would have 5x squared minus 3 equals 0. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Well, in this case, a is equal to 5, b is 0, and c is negative 3. All right, so x equals the opposite of b is going to be 0, then plus or minus the square root b squared is 0, then minus 4, a times c is negative 15, then all over 2 times a is 10. So I get x equals plus or minus negative 4 times negative 15 is 60, so plus or minus the square root of 60 over 10. And if you take square root 60, that's 15 times 4, so it'll be plus or minus 2 root 15 over 10. And notice the 2 and the 10 can reduce with each other. They would reduce to 1/5, so you would get plus or minus the square root of 15 over 5. And notice you get the same answer if you solved by taking square roots or if you solved by using the quadratic formula. Which way was faster? Solving by taking square roots was a lot faster than using the quadratic formula. So if you can recognize at the start of the problem that you don't have to use the quadratic formula, that's going to be beneficial to you because it's going to save some time. Same thing with number 2. We have x squared equals 3x minus 4. We'll put it in standard form, so subtract the 3x and add the 4 to both sides. and you get x squared minus 3x plus 4 equals 0. Could you solve using the quadratic formula? Absolutely. But if you recognize at the start that this factors, right, can you multiply to positive 4? Oops, nope, it doesn't factor. I lied. Let's change this to a plus 4, and then it's going to factor. So change this to a plus 4 because I just want to demonstrate what I mean by sometimes it's going to be nicer. So if I change that to a plus 4, then I would subtract 4 and subtract 4. And now if you recognize that this factors, can you multiply to negative 4 and add to negative 3? Yeah, that's going to be x minus 4 and x plus 1 equals 0. So either x minus 4 is equal to 0 or x plus 1 is equal to 0. So my two solutions are 4 and negative 1. Now, if you can recognize before that it factors before you try and use the quadratic formula, that's going to make the process of solving a lot faster. Could we use the quadratic formula? Yes. X equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. So in this equation, a is 1, b is negative 3, and c is negative 4. So x is going to equal the opposite of b. The opposite of b is 3, plus or minus the square root. B squared is negative 3 times negative 3, which is 9. Then minus 4 times a times c. Well, a times c is negative 4. All over 2 times a, that would be 2. So x is going to equal 3 plus or minus the square root. 9 minus 4 times negative 4 becomes 9 plus 16, which is 25. And then all over 2. Well, the square root of 25 is 5, so it's going to be 3 plus or minus 5 over 2. So x equals 3 plus 5 divided by 2, or x is going to equal 3 minus 5 divided by 2. Well, if you simplify this, 3 plus 5 is 8. 8 divided by 2 is 4, so one of my solutions is 4. 3 minus 5 is negative 2. Negative 2 divided by 2 is negative 1. So notice we got the same solutions using the quadratic formula as we did by factoring, but factoring was a whole lot faster than having to use the quadratic formula. So just be aware when it's asking you to solve a quadratic equation, you now have several methods that you can use to solve. You can take square roots, you can try to factor it, you could solve by completing the square, or you can solve using the quadratic formula. All right, so let's look at the following. 1/5 x squared minus x equals 1. So let's put it in standard form. So subtract the 1, and we have 1/5 x squared minus 1x minus 1 equals 0. Could we leave a equals 1/5 as part of the problem? Absolutely. So you could use a equals 1/5, b equals negative 1, c equals negative 1 if you wanted to solve that way. If you don't want to have to substitute in a fraction for the quadratic formula, we can multiply the entire equation by the denominator to get rid of it. So I can multiply every term in this equation by 5, and then I won't have to deal with a fraction in my quadratic formula. So 5 times 1/5 is 1, so I have 1x squared. 5 times negative x is negative 5x. 5 times negative 1 is negative 5. 5 times 0 is 0. Now, when I use my quadratic equation, my a is going to be 1, my b is going to be negative 5, and my c is going to be negative 5. This doesn't factor. I can't multiply to negative 5 and add to negative 5, so I'm going to have to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So x is going to equal the opposite of b is 5, then plus or minus the square root. B squared would be negative 5 times negative 5, which is 25. Then minus 4, a times c is negative 5. All over 2 times a is 2. Negative 4 times negative 5 is 20. So under my square root, I'm going to have 25 plus 20, which is 45. So x is going to equal 5 plus or minus the square root of 45 over 2. The square root of 45 is 9 times 5. So this is going to be 5 plus or minus 3 radical 5 over 2. And that would be the solutions to that quadratic equation. All right, why don't you guys try number 2? So pause the video and try number 2. All right, so get it to equal 0, so subtract 2 from both sides, and we get 1/2 x squared plus 4x plus 1 is equal to 0. We can get rid of the fraction by multiplying every term by 2. And we would get 1x squared plus 8x plus 2 equals 0. So a is going to equal 1, b is going to equal 8, and c is going to equal 2. So x is going to equal the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So x is going to equal negative 8 plus or minus the square root of 64 minus 4 times 2 all over 2. So x is going to equal negative 8 plus or minus the square root of 64 minus 8 is going to be 56, and then over 2. The square root of 56, well, 56 divided by 4 is 14, so this is going to be negative 8 plus or minus 2 square root 14 over 2. And notice all of these are divisible by 2, so I can divide them all by 2. And I would get negative 4 plus or minus the square root of 14 over 1, or negative 4 plus or minus the square root of 14. All right, so that's solving using the quadratic formula. All right, so now we're going to solve the quadratic formula, and then we're going to use our calculator to come up with the decimal answers that would correspond to our square root answers. So x squared minus 9x plus 7 equals 0. So a is equal to 1, b is equal to negative 9, c is equal to 7. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So x is going to equal the opposite of b is 9, then plus or minus the square root. B squared, negative 9 times negative 9 is 81, then minus 4 times a times c all over 2 times a. So x is going to equal 9 plus or minus the square root of 81 minus 28. So that's going to be 53 over 2. So those are my exact solutions. So when you leave the square root in, you're getting your exact solutions. If we want to approximate our solutions, well, we're going to approximate both. So 9 minus the square root of 53 divided by 2, and 9 plus the square root of 53 divided by 2. These are going to give me approximate answers. So now on our calculator, we're just going to do 9 minus the square root of 53, and then hit enter, and then you're going to divide that answer by 2. And if you take 9 minus the square root of 53 and divide by 2, you're going to get, we'll round out to 3 decimal places. We'll round out to 2 decimal places, 0.86. So that is an approximate answer. So x is approximately 0.86. Or we can do 9 plus the square root of 53 and then divide that answer by 2. And you get your other solution would be x would be approximately, round out to 2 decimal places, 8.14. So my 2 approximate answers to that quadratic equation are x equals 0.86 and x equals 8.14. So why don't you guys try number 2? Come up with the exact solutions and your approximate solutions using your calculator. All right, so a is going to be 3, b is negative 6, and c is 1. So x is going to equal the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's going to be 36 minus 12, which is going to be 24. So x is going to equal 6 plus or minus the square root of 24 over 6. So that's going to be 6 plus or minus 2 square root 6 over 6. All of those are divisible by 2. So 3 plus or minus the square root of 6 over 3. So those are going to be my exact solutions. My approximate solutions are going to be, we're going to use that first one. So 6 plus the square root of 24 divided by 6, and 6 minus the square root of 24 divided by 6. So if I use that, I would get 6 minus the square root of 24, and then divide that answer by 6. And I get x equals 0.18 as one of my approximate solutions. And then 6 plus the square root of 24. And then divide that, divide that by 6. And you get your other solution to be 1.82 if you round. So those would be my two approximate solutions. All right. So in the quadratic formula, if you recognize that we had x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, the terms underneath the square root have a special name. So that b squared minus 4ac, we call that the discriminant because it tells us how many solutions we'll have and what types of solutions they'll be. So if b squared minus 4ac is positive, so if you get a positive number under your square root, then you are going to get two real solutions to your quadratic equation when you try and solve. So if b squared minus 4ac is positive, then you're going to get two real solutions. If the b squared minus 4ac is negative, so if the number underneath your square root ends up being negative, you're going to have no real solutions to your quadratic equation, because remember, you can't have a negative under your square root. And then the last option, if b squared minus 4ac is 0, so if you get a 0 under the square root, then you're going to get one real solution. So you're only going to get one answer to the equation. So those are your three options that you could get for the discriminant. Again, the discriminant is going to be the number that you get under the square root. If that number is positive, you'll get two real answers. If that number is negative, you'll get no real answers. And if that number is 0, then you will get one answer, one real answer. So use the discriminant to determine the number of solutions. So our quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. But the only part that I care about if they're asking about the discriminant is the b squared minus 4ac. Well, a is 1, b is negative 10, c is 35. So b squared minus 4ac will give me, b squared is going to give me 100 because negative 10 times negative 10 is 100. Then minus 4 times a times c would be 4 times 35. And 4 times 35 would be 140. So I get 100 minus 140, which is negative 40. So in this part of the quadratic formula, I would get negative 40. And so in my formula, I would get the square root of negative 40. Well, you can't take the square root of negative numbers. So since my discriminant is negative 40, I'm going to have no real solutions to that quadratic formula. All right, on number 2, 5x squared plus 3x equals 0. So my a is equal to 5, my b is equal to 3, and my c is equal to 0. So the discriminant is b squared minus 4ac. So b squared is going to be 9. Then minus 4 times a times c, that would be minus 4 times 0. So my discriminant is 9. Well, if I took the square root of 9, I get a positive 3. And since that is positive, I'm going to get two real solutions. So since my discriminant is positive, I'm going to get two real solutions if I use the quadratic formula to solve. All right, so why don't you guys use the discriminant to determine the number of solutions? All right, so a is equal to 1, b is equal to 1, and c is equal to negative 2. So remember, the discriminant is b squared minus 4ac. It was what was under the square root. So b squared is 1, then minus 4 times a times c. That would be negative 4 times negative 2, so that would be 8. So my discriminant is 9. Since my discriminant is positive, I'm going to get two real solutions. All right. So using the quadratic formula in a word problem. So the area of a rectangular garden is 95 square feet. If the length of the garden is 7 feet longer than its width, find the dimensions of the garden. Round each answer to the nearest 10. So the area of a rectangular garden is 95 square feet. So we've got a rectangular garden, and then the area of this garden is 95 square feet. If the length of the garden is 7 feet longer than its width, so we don't know the width, so I'm going to say x equals the width of the garden. So we'll call those sides x. if the length is 7 feet longer, so 7 plus x, or x plus 7, is going to equal the length of the garden. So these sides would be x plus 7 and x plus 7. Find the dimensions of the garden. Well, to find area, remember, we're going to take length times width, or width times length. So in this case, the area of my garden is going to be x times x plus 7. And the area of my garden was 95 square feet. So x times x plus 7 is going to equal 95. We'll distribute, and we get x squared plus 7x equals 95. Notice now we have a quadratic equation to solve. We can't solve by taking square roots because I have x squared plus 7x. We're going to get this in standard form, so I'm going to subtract the 95 over, and we get x squared plus 7x minus 95 is equal to 0. Well, could I factor it? Could I multiply the negative 95 and add to 7? I don't think so. So we're going to use the quadratic formula. A is going to equal 1, B is going to equal 7, and C is going to equal negative 95. So x equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So x is going to equal negative 7 plus or minus the square root of B squared is 49. Then minus 4 times A times C would be 4 times negative 95 all over 2 times A. So that'd be all over 2. All right, 95 times 4 gives me 380. So I'm going to get x equals negative 7 plus or minus the square root of 380 over 2. Now I'm going to use my calculator to solve. So x is going to equal negative 7 minus the square root of 380 over 2. Or x is going to equal negative 7 plus the square root of 380 over 2. So negative 7 minus the square root of 380, and then that whole answer divided by, that whole answer divided by 2. And so if I use the negative solution, I would get the width to be negative 13.25. Widths can't be negative, so I know that's not going to be my solution. So let's try the other one. Negative 7 plus the square root of 380 divided by 2. In this case, I get x to be 6.25, and that's positive. So the width of my rectangle, it says round to the nearest tenth, so what was that? 6.2. Sorry, it said nearest tenth, so I'm going to round that to 6.2, so it's the nearest tenth. So the width of my rectangle is going to be 6.2 feet. And then the length of my rectangle is 7 plus that. Well, 7 plus that would be 13.2 feet. So the width of my rectangle is going to be 6.2 feet, and the length of my rectangle is going to be 13.2 feet, rounding to the nearest tenth. All right, your homework is from 10.3. Let me know if you have any questions.